Let's journey way out to the edge of our solar system, to a pale, quiet, blue-green giant that's literally spinning on its side. We're talking about Uranus, a world that is just shrouded in mystery. And, for almost all of human history, pretty much everything we've learned about it came from just one single fleeting visit. I mean, just let that sink in for a second. With all of our space exploration, all our probes and rovers, only one robotic visitor from Earth has ever made the trip. Not a whole fleet of ships, just one solitary probe, Voyager 2, on a one-shot flyby that would completely change how we saw this corner of the solar system. And what a trip it was. It took 8.5 years, think about that, 8.5 years for Voyager 2 to cross that immense empty space just to get to Uranus. It was such a long, lonely flight to a world nobody had ever laid eyes on up close. So you have to ask, why, right? Why would we ever commit to a mission that was so incredibly long, so difficult, all for just a quick little peek at a far-off ice giant? Well, the answer? It has everything to do with some cosmic luck and absolutely brilliant timing. See, it all came down to the celestial event that was so incredibly rare, it was a genuine once-in-a-lifetime shot. Back in the 1960s, scientists figured out that the giant outer planets were about to line up in a way they hadn't for almost 2 centuries. Jupiter, Saturn, Uranus, and Neptune were all getting into position. It hadn't happened since the 1800s, and it wasn't going to happen again until way out in the 2150s. This was it. A 1,750-year golden window, the chance to visit all of them with a single spacecraft. If we missed it, we'd be waiting for generations. And the plan they came up with was just ingenious. They called it the Grand Tour, and it was all based on this technique called a gravity assist. The idea was to use the massive gravity of each planet to basically slingshot the spacecraft toward the next one, picking up speed and saving decades of travel time. It was like playing a game of cosmic-scale planetary billiards. But trying to pull off a trick shot like this came with unbelievably high stakes, especially because the tech back in the 60s and 70s was nowhere near as reliable as what we have today. So to make sure they didn't blow this golden opportunity, NASA didn't build just one probe. No, they built 2, the Voyager twins. The pressure was just immense. I mean, one tiny little malfunction, a single error in a calculation, and the whole mission could be over. And with a 175-year wait for the next shot, well, failure just wasn't an option. Having a backup was absolutely critical. So they basically hedged their bets. Voyager 1 got sent on a faster path, with its main job being to study Jupiter and Saturn. That included a really risky but high-reward flyby of Saturn's amazing moon, Titan. Meanwhile, Voyager 2 was the official Grand Tour probe. If anything went wrong with Voyager 1, Voyager 2 was all set to take over and complete the full 4-planet tour. In the end, both missions were a spectacular success. Voyager 1 nailed its flyby of Titan and got flung out towards interstellar space, becoming our first ever emissary to the stars. And that left Voyager 2 to carry on with the Grand Tour all by itself, beginning that long, silent, 8.5-year flight to the great unknown, Uranus. The impact when it finally arrived was immediate and just staggering. Before Voyager 2 got there, we only knew about 5 moons and 9 rings that were so dark they were described as being blacker than coal. Then, in just a few days, the probe found 10 brand new moons and 2 new rings. It completely rewrote the textbooks, like overnight. But Voyager's mission was about way more than just counting moons and rings. As it got closer, it started to show us that Uranus wasn't just some simple, boring ice ball. Oh no, it was a world full of bizarre and totally perplexing mysteries that really challenged our whole understanding of how planets are supposed to work. Okay, so to get the first big mystery, we need to do a quick refresh on magnetic fields. Just think of it as an invisible force field that a planet generates from its hot spinning core, kind of like the one we have here on Earth. It basically acts like a giant bar magnet, and it's usually lined up pretty well with the planet's spin. But Uranus's magnetic field is just a complete mess. It's tilted by a whopping 60 degrees from its axis of rotation, and it's not even centered on the planet's core. And to top it all off, it was way stronger than anyone expected. This discovery just broke all our neat little models and suggested that maybe some weird, slushy ocean of what they call hot ice deep inside was causing all this chaos. And here's another huge puzzle. Remember how Uranus spins on its side? Well, that means one pole faces the sun for decades straight, while the other is in total darkness. Logically, you'd think the sunny pole would be a lot warmer, right? But Voyager 2 found that both the sunlit pole and the dark pole were the exact same frigid temperature. How is that even possible? To this day, we still don't have a good answer. So Voyager 2's quick visit gave us our first real look at this strange world, but it honestly left us with way more questions than answers. The mysteries it uncovered were so deep, so profound, that scientists knew we absolutely had to go back. And that brings us to the future. There's a new mission in the works called the Uranus Orbiter and Probe. The plan is to send a dedicated orbiter that will stick around for years studying the planet, and it will even drop a probe down into that mysterious atmosphere. It's slated to launch sometime in the 2030s and arrive in the 2040s. So this next mission, it'll be our first trip back to Uranus in over half a century. It just makes you wonder, after all this time, what other mind-bending secrets has this tilted giant been hiding out there, in the cold, just waiting for us to come back and finally uncover them?